Bismillah ar-Rahman ar-Rahim. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to another live lesson by Lady Khadija Online College. Maths A-Level Year 2 Pure Maths following the Edexcel Pearson syllabus. That's the UK Pearson Edexcel syllabus. Today's topic is modeling with trigonometric functions. And this is just a complicated way of just saying word problems with trigonometric equations. And the reason why we say the word modeling instead of calculating or calculations is because these kind of problems are real life problems, real life scenarios, and the calculations will never give you the exact answer that works in real life. In real life, there's too many factors involved. So you're only ever going to get close to the real answer, and that's why we call it modeling. Modeling is when you're kind of getting very close to the real answer in real life, but you, you're not expecting it to be perfect. So it's called modeling. Let's begin. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. We have a word problem which is a lot of words, but hopefully the maths will be quite easy. So let's just take a read through. We're talking about an aeroplane flying in the sky and it reaches a certain altitude and then it cruises at that altitude for a while. And as it cruises at that altitude, the pressure in the air cabin changes. So let's start from the beginning. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. The cabin pressure, P, and that's measured in pounds per square inch, PSI, in an aeroplane or on an aeroplane at cruising altitude. At cruising altitude, that's the height that it's just going at a steady speed, can be modeled, so it's not an exact, not going to give us a perfect answer, but it's going to be pretty close, by the equation P, the pressure, is equal to 11.5 take away 0.5 times sine brackets t minus 2. The t is the time in hours since the cruising altitude was first reached, and the angles are measured in radians. Question number 1 is, can we work out the maximum and minimum cabin pressure? Okay, this is easy to do if the equation that you've got is based on sine or cos, because you have to remember that the sine curve, if you just do a quick sketch, and also the cosine curve. Let's do the sine curve first. So the sine curve is a curve that goes up and then down and then back up. It'll always reach the same height when it comes back up, and then the same minimum when it goes back down. So this minimum here and this minimum here will always be the same. The maximum is always going to be the same. What is that maximum and minimum? The maximum is 1 and the minimum is minus 1. So if we're trying to find the maximum and minimum, it's very easy if your formula is based on sine or cos, because you know the sine part, the maximum will only ever be 1, the minimum will only ever be minus 1. And that applies to both the sine and the cos. So if we just take a copy of this equation, and if we put the maximum value we can put in for sine, it doesn't really matter what that angle is, but the sine curve, meaning the sine function here, the maximum is ever going to be 1. So let's replace that and put in 1. So that'll just be times by 1. And let's work that out. 11.5 take away 0.5 times 1 is equal to 11. Or remember the sine curve can go down as well, and it can go down to -1. So let's do the same thing but with putting in -1. So that'll be 0.5 times -1. And that will be equal to 2 minuses make a plus. So that will be adding 0.5. So that would be equal to 12. So for the word problem, they wanted to know what the maximum value of p would be and the minimum. The maximum is going to be that one here. That's your maximum. It's the highest one. And the 11 is going to be your minimum. Okay, nice and easy because you know that sine and cosine graphs, they'll only ever get to 1 and -1. Okay, next part is, can we work out, given that the maximum pressure that we worked out in part A is 12, can we find T? When does that maximum pressure occur? So here we're just going to do a bit of substitution and then solve it. So here, let's take the equation. Now we know what P is. They're asking us to find out the T when the pressure is 12, when the pressure is at maximum. So let's swap the P for 12. And then let's rearrange and solve that. So let's start by adding 0.5, or let me just do it the quick way. So let's make some space. And then I can take the minus 0.5 sine 2 minus 2 to the other side. A bit more space. And that minus is going to become a plus. I can take the 12 to the other side. That 12 is going to become a minus 12. 11.5 minus 12 is minus 0.5. So I might as well write that in. Here we've got minus 0.5. On the other side, we've also got 0.5. The plus doesn't make any difference, so that can go. So let's divide by 0.5. Let's take the 0.5 here and put it onto the other side as a divide. So that's minus 0.5 divided by 0.5. That's going to become a minus 1. And if you then inverse sine minus 1, you'll get your first answer on your calculator. So t, by inverse signing, on the left-hand side, I'm just left with t minus 2. And on the right-hand side, whatever your calculator gives you for inverse sine of minus 1, that will be minus pi over 2. To get the second answer for a sine graph, you have to remember that the answers add up. The pair will add up to 180 degrees, or that's pi. So you just want to do 180 degrees, take away your first answer, or pi, take away your first answer to get the second answer, and that will be 3 pi over 2. And there's more answers as well. The curve repeats every 360 degrees, so you can just keep adding 360. Okay, now let's add 2 to everything. So we're adding 2 to every single answer here. So minus pi over 2 is going to become 0.43 rounded off. And the other answers we can ignore because in the question we're just looking for the first time that this maximum pressure is reached. So that's 0.43. The time is in what units? Let's take a look. It says here where t is the time in hours. So that 0.43 is hours. We probably want to change it to minutes. Let's times by 60, and that'll change it into minutes, and that will be 26 minutes rounded. Okay, good. So that's how we deal with word problems in trigonometry, in trigonometric functions and ratios and identities. Join me for more. The next chapter is going to be a new one, so join me for that, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.